Good afternoon, class. Welcome to EEE 322 course, which is electrical engineering practice. And this afternoon, I want to make a short presentation on the application of Simulink in solving differential equations. The application of Simulink in solving differential equations. So we'll go straight to working out a problem, an electrical circuit problem. The initial conditions for the circuit below are given as IL at time 0 is equal to 0 and VC at time 0 is equal to 0.5 volts. Use Simulink to simulate VC. So the circuit under consideration is as shown. So we have a DC source, a DC source connected in series with a resistor, an inductor, and a capacitor. So we may call this a DC RLC circuit. DC RLC circuit. Okay. So now the question is, or the task is to use Simulink to simulate VC of T, which is the voltage across the capacitor. So we have the DC source connected in series with a resistor, an inductor, and a capacitor, and the arrangement is as shown. So let's see the procedure. Maybe before we move to the next slide, let's look down here. We have this condition. Say Vs of t is equal to UO of t. Vs of t is equal to UO t. So using Kirchhoff's voltage law, we obtain RC dVc over dt plus LC d2 Vc over dt squared plus Vc equals UOT. Substituting the values of the circuit constants and rearranging, we get the equation d2 Vc over dt squared plus 4 dVc over dt plus 3 Vc is equal to 3, where t is greater than 0. Then by analytical method, the solution of this differential equation gives the answer as Vc of t is equal to 1 minus 0.75 e raised to the power negative t plus 0.25 e raised to the power negative 3t. So now to model the differential equation using Simulink, we set up the following block diagram. So UO of t is at the input side and Vc is at the output side. So this can be realized in MATLAB Simulink. Okay, we'll move to the next slide. The completed block diagram should look like this. So this is how we expect it to look once completed in MATLAB Simulink. And next, if you double click on gain blocks and on the function block parameters window, you can vary, or you can put in the appropriate gains as a requirement. The initial conditions are entered by double clicking the integral, the integrator blocks and entering the values 0 for the first integrator and 0.5 for the second integrator. To see the output waveform, we click on the Run button and then double click on the scope block. The waveform for the function VC should look like this. So this is how the function for VC should look. Okay, so it's a very, very short presentation, but showing all the key stages that are needed. Okay, so this is what I expect you to obtain after having followed all the stages. So I'll run through the procedure once more. So we get back to the first slide. So we have the initial conditions for a circuit given as IL0 is equal to 0, then VC0 is equal to 0.5 volts, and we're asked to use Simulink to simulate VCT. So we have an RLC circuit that is connected to a DC source. Yeah. So here we are being told to say the supply voltage VST will be represented by U or T. Yeah, so those are the values. For R, we have 1 ohm. For L, quarter Henry. For C, we have 4/3 farads. And the question is demanding that we get a simulated output for VC. Okay? So using Kirchhoff's voltage law, we're able to obtain the differential equation RC dVC over dt plus LC d2 VC over dt2 plus VC is equal to UO of T. Then substituting the values of the circuit constants and rearranging, we get d2 VC over dt2 plus 4 dVC over dt plus 3 VC is equal to 3. On condition that T is greater than 0. Then by analytical method, the solution to this differential equation, you can even prove it. Yeah, you need to verify that this is indeed a solution to that differential equation, okay, given the initial conditions stated above. So this is the equation that is got by analytical means. So to model the differential equation using Simulink, we set up the following block diagram. So this is an interpretation of the differential equation that we just saw on the previous slide. To complete the block diagram in Simulink, we expect that it should look something like this in Simulink. Then to change the values of the gain blocks as well as whatever block parameters is appearing here, we simply double click on the particular block and input the appropriate value. So the initial conditions are entered by double clicking the integrator blocks and entering the values 0 for the first integrator and 0.5 for the second. To see the output waveform, we click on the Run button and then double click on the scope. So after having done that, we expect that the output should look like this. So this is the simulated output of VC. So now here's an assignment which each one of you is supposed to submit. Connect the block diagram in Simulink and run the simulation to display the waveform. Derive the differential equation from the block diagram. Okay, so this is the block diagram. Okay, so this is the assignment. We expect that everyone is supposed to submit. So the next time we have a lecture in electrical engineering practice, we should be able to look at the different solutions that you are going to get. Okay, so for now, it's goodbye.